Welcome to Competency 14 Practice Quiz, Part 1 of 3. In this video, we will work with practice quiz questions. Number 6. In rhombus EFGH, the coordinates of E are -4, -3. All right, let's go ahead and just draw that in. -4, -3. Well, there's 1. And the coordinates of G are 3 and 6. And let's put it right there. Okay, you know what? Let's label these. Okay. And that is E. Okay. That's just EG. Okay. R3, 6. If the area of EFG is 90, what is the length of the diagonal of FH? Okay, here's the thing. This is a diagonal of a rhombus. We know to get the area of a rhombus, you must take the diagonal 1, multiply that by diagonal 2, divide by 2, and in this case, that area equals 90, okay? So we have D1. So let me erase that, and we can put in that value. Not until they don't give it to us. So what do we really have to do? We have to solve the Pythagorean theorem to get that distance, okay? So let me do this. We have a base and a height. And honestly, you can just count from, because we have right angles. So we have the base and literally count the squares. And then going up, we have 9. Here's the thing. On a test, it's highly unlikely they're going to give you a grid. I put this in for our own ease. You can just simply, sketch it out for yourself and figure this out. Okay, so what we're going to do is we will put under the radical, we need to square the 9, which is 81, and then, we add that to 7 to the second power, which is 49. Okay? That does not look like addition. Let's make that addition. Okay. So we can just put all this in the calculator. But first, how about we multiply both sides by 2? So that means we have 2 here times 2 here. That will cancel out. And then what it really is the value of D2, our diagonal 2. D2 actually equals 2 times 90 is 180 divided by the square root of 81 plus 49, which is 130. Okay, let's put all that in the calculator. Let's just double check all this, okay? So first, under the square root, just to double check my mathematics, we have 7 to the second power plus 9 to the second power. That should be under the radical 130, but that comes out to roughly 11 point da 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 da. Okay, let's leave that. So 7 squared plus 9 squared actually does equal 130. Okay. All right, so we know what that is. When we put it under the square root, put it under the radical, pull it out, we're going to get 11.4 and we can round. Okay, now let's do this. 180 divided by under the square root, 130, do we get an option that works? Yes, when we round, we get option A. So I did a little bit more than what we really needed, but you can see how I got that. Now, what does that require? That requires you remembering how to get the area of a rhombus. And that's not something I know I have it rolling around in my head, but that's not something everyone has in their head. So it might do you some good to look at the properties of certain shapes, your parallelograms. You could be asked questions about those. And remember, those will not be given to you on a formula sheet. All right, let's look at number 7. Okay, in triangle M and Q, the coordinates of M and Q are, okay, let's go ahead and label this. The first one is M because they say respectfully. So that means N is here, M is here, N is here, and Q is here. Okay. And that's how we'll put it in our graph, which again, I put in a snippet of a graph so we could graph it for ourselves. When you're taking the test, you will have to sketch these quickly. Okay, so let's see what we have here. We have 5 and 3. Okay, and we're going to call that one M. And then 1 and -4. Call that guy N. Oops. Too many up and down there. Call him N. And then Q. We've got 9 and -3. Okay, call that guy Q. Okay, what are we doing here? We are drawing a line here and here and here. Here's the thing. They are asking, what is the slope of the altitude of M to NQ? Okay, first off, the slope of the altitude, this implies that you go straight down. This is 90 degrees, okay? So then we need to know what the slope of NQ is. Well, obviously, rise over run, that will be 1 over, well, from here, from 1 to 9, that would be 8. So rise over run gives us 1 over 8. But we are concerned of this altitude that is perpendicular from N to the line NQ. This implies we need the negative reciprocal, and the reciprocal of 1/8 is 8, and that would be option B. Number 8. Which one of the following equations represents the graph of a circle whose center is located at 6, -5, and whose radius is 4? Okay, this is just a matter of knowing the properties. The first thing that I need to point out to you is that for our equation, we have r squared, right? Will be on the right side equal to r squared. For us, that means 4 squared, and 4 times 4 is 16. Option C and D will not satisfy. So now we're left with A and B. Now, this is in center form, meaning that you use the values of the center. So that tells me we will have x minus 6 as is. B satisfies. A does not. And then we should have y minus -5. And a minus times minus is positive. So B is the only option that will satisfy. Okay, now let's go to number 9. Okay, the equation of the ellipse is given as, here it is, in one of the foci, if one of the foci is 311, which one of the following represents the coordinates of an endpoint of the vertical, ooh, that's important, vertical major axis. Okay, So I know that my major axis will be vertical. It will be straight up and down. Okay? All right. So here we go. Straight up and down. That's a little better. Now, one thing I do know is I have a center at 3, -1, and I have a foci above that of 3, 11. Okay. Well, from this, I know that the distance between those is 12. And I also know because that distance is 12, the other end, I know that I need to subtract 12 because the distance is still 12. Okay. So then if I do that, I see that that will be 3. And -1 minus 12 is -13. So that gives me those distance. Okay. Now, before I start eliminating anything, we do need to look at this fact. We know that A is equal to 12. First off, we know that B is 9 and A is equal to 12. Okay? Now, let's put this in the calculator. Now, how do I know that A is 12? Which is which? Well, my major axis was told to me in my problem, and that is vertical, implying that it is parallel to the y-axis, and it is in the denominator below the y-axis, and that is how I know A belongs. Okay. And honestly, we should use capital A. So let's look at that in our calculator. There's a couple of things going on here that we need to point out. Okay, so we need to go to apps. Oh, let's go second mode. Okay, there's our apps. Okay. And we go to 4, down to 2, which is an ellipse. Now we need the second one. Notice the position of your A and B. We want A to be below this major Y here. Okay, so go down, enter it. Okay, what we need is already in our calculator. See, A is our 12, 9 is our B, 3 is associated with H, and -1 is associated with K. Perfect. Okay, so let's graph that. Now that does not look like a major axis is vertical, and I'll tell you why. Take a look at how your spacing is on your x-axis, and then look at your spacing on your y-axis. The y-axis seems to be shrunk. Just in case. Now don't back out and say, "Oh, that looks wrong. That can't be right." Don't do that. Before you do that every time. And if you watch the other videos with me, you may have seen me do this. Push mode, and you're on function, which is fine, but go to auto, from manual to auto. It's really hard to judge when to use one or the other. For manual, you just want your hyperbolas and parabolas to scoot over a little bit, look a little better. But in this case, leave it on auto. Okay. Now let's escape, which gets us back, and we can graph again. There it is. And that's exactly how it should look. And notice the spacing. Your scale spacing on your X and Y axis are appropriate. They look even or equal. Okay, so this is better. Great. So let's go ahead and trace. Okay, I'm going to go up to the top, and let's make sure that gives us 311. Okay, now that gives us an ellipse, but that ellipse, okay, that doesn't give us everything we need. We need what they're asking for is end point of the major axis. This is not exactly a precise ellipsis. Okay, not a big deal. Okay, so we need to change what we're doing. So what we need is C equals. So our A isn't exactly correct. Okay, so we need A squared equals, I'm sorry, C squared equals A squared plus B squared. So for us, we need that C, which is going to give us that full distance of from one end to the other, and that will equal under the radical A squared, so that gives us 144 plus 9 times 9 is 81. And let's put that in the calculator. Second mode, and let's quit. Okay, under the radical, I'm going to go ahead and say 12 squared plus 9 squared. Let's see what we get. 15. Now, remember, this is vertical, and you're going from one end to the other, the top to the bottom. So this would mean plus or minus 15. So go over here to your y value at your center, and we will add 15. And this means that we have 3 and 14. Okay, if you go up 15 from -1, that implies that up here at this endpoint, we will have 314. Okay, well, that's not an option. Okay, well, because that's the top endpoint, that means this is not going to work because that's a -3 for the x value. And we can't have anything above 14. So A and B are no longer an option. So let's see here. We should have D. Well, -1 minus 15 definitely means that down here, this endpoint will be 3, -16, because -1 minus 15 is this -16. So option D is correct. That was a lot to get there. And I really disagree with how they have this A here. It's very misleading. So let's go back and put that in the calculator. I used that focus. I got us a picture, but I'm wondering if we should try under that square root. Let's see if we could use 15 squared, and let's look at what it gives us, okay? So let's go apps and go to 4 and 2 and go back to 2 again. So what did we say? We're going to use 15 here, 1, 5. Everything else remains the same. I'm going to push enter just in case and graph it. Okay, that looks more like it. And let's trace, go to that endpoint, and that's 314, and that's what we had. So what we did is we used our notation isn't quite right. I don't quite like the way they did that. I would have preferred that we had, uh, well, c squared. No, it still works in its way, but I'm not a fan. The way we got there was correct, but this notation is iffy. Oh, sorry. This notation here, I disagree with how they explain it, but I was okay with figuring this out, going through the motions, because I understood the major, the minor, and I knew the properties. So that got me there. And in the end, I have an appropriate picture, so I'm okay. So let's go to number 10. The sum of the distance from any point of an ellipsis to the focus is 24. And the length of the vertical minor axis is 10. If the center is at the origin 0, 0, what is the ellipse? Okay, this is what I was talking about on the other one, where they had that a squared. I debate the way they did that. It doesn't matter now. But for us right now, we are okay. So we know the vertical is a minor. Okay, so we, at this point, we know B equals 5 because half of that. And we know that A equals 12. Okay. And then the major axis is horizontal because the minor is the vertical. And if it's horizontal, that means it's parallel to the x-axis. So our 12 should be underneath, our 12 squared should be underneath the x squared, okay? First off, this is 13 squared here with A, that will not work. With B, that is 13 squared, so I disagree with that. So then we have C and D. And I have just explained that our focus should be here. Our focus, our center is at 0, 0. And then you have a focus here, and then an endpoint and an endpoint. So that means x squared over 144 is what we're looking for. So that will be option C. Obviously, they're crisscrossed here, so that will not work. Okay, now, oh, I see a small typo I can fix real quick. There we go. Okay, for this one on number 11, it's a little different from what we saw before. What is the distance between the vertex and the directrix of the graph of the parabola x squared minus 20y minus 100? Okay. All right. Try to get that to come off. It doesn't matter, I suppose. Okay, there it goes. Okay. So what we need is a value of p. Okay. All right. So let's work with this. We need to change the form. How does this look? Okay. Well, we have an x squared. And that's really kind of like saying plus 0 because we don't have a, a number, a coefficient like plus 2x minus 20x. We don't have that. So we know everything there is just 0. Okay, then we move the other two numbers to the other side. So we have 20y plus 100. Now, we just don't worry about the left side. It's not going to get us what we need, obviously. So what do we need to deal with here? We know that this 20 is what we need to look at. So it's going to be 4. You always have to pull out a 4. Remember that. And then the 5. And then that gives us y plus 20. Okay. This is our p. That's our distance, 5. Obviously, that's option B. Okay, that is the last video of part 2 of your practice quiz questions. Don't forget to share us, like us, and subscribe. And please watch the next video, 3 of 3 for your quiz. Happy testing!